Good evening, guys. Welcome to a new series on this channel. This is all going to be about pseudo-labeling, which is a a version of self-supervised machine learning, right? So the reason why I am recording this is because this was part of my master's research that I submitted about a year ago to this date, right? So it's titled Facial Action Unit Classification Using Weakly Supervised Learning, right? So essentially, the whole premise or the whole idea for this research was that right now we have deep learning models that are busy, well, they've gained a lot of popularity because of their performance with large data sets, right? However, the challenge or bottleneck is that the process of annotating or labeling or even creating data sets is actually expensive, right? So when it comes to deep learning, you are limited by the quality and amount of data that you have. So your model is only as good as your data. So essentially now weakly supervised learning is an area of machine learning where you can have, how do I put it now? Inaccurate or suboptimal, yes, let me use suboptimal data sets, right? And then you can use those data sets to train a model, right? And the aim is to get the same almost a reasonable performance, right? As compared to those trained with optimal data sets. All right. So in this research, I had two self-supervised or weakly supervised approaches. The first one was large loss rejection, right? So essentially it will look for any I guess prediction that has a large loss and will reject it because we have we fed it noisy data, right? So there's a little bit more to that you can read on large loss rejection, right? And then the next one was pseudo-labeling, right? So, and that's what we're going to be discussing in this video, right? So in pseudo-labeling, what happens essentially is that you have a limited amounts of labeled data, and then you have a large amount of unlabeled data. So you train a model on your labeled data and then predict on the unlabeled data, and then you take those predictions and the unlabeled data and train a model again, and you continuously go through this can I say cycle or loop until you reach suboptimal performance, right? I mean, not suboptimal performance, but optimal performance, right? So rather than me babbling all over this, you can check it out. However, we can here's a little explanation. So you have your labeled data, you train a model with this, then you take your unlabeled data, right? You make a prediction on this, and then you combine these two, right? So the prediction on this unlabeled data will be your Y, and then this is going to be your X, right? X and your X being your features, Y being your target or prediction, or what's the features and target, right? But this is a predicted, and then you now combine this to have another model, then you train it, and then you follow this loop, and then you, yeah, try and see if your model will improve in performance, right? So this is you can check this out. It's a very good resource and explanation of how pseudo-labeling works, right? So yes. So pseudo-label our target classes for unlabeled data equate true, right? So if our prediction is higher than some value, then give it a 1, otherwise a 0. Pseudo-label is used at a time. Fine-tuning phase or dropouts, right, is trained in a supervised manner with labeled and unlabeled data, and then you have a loss where over your data sets, this is the loss, right, for your, what would this be now? On this side is your labeled data, and then this side is your predicted unlabeled, my labeled data. And then there's now this little decay function there, or a weight to penalize your predictions on or the loss on your unlabeled data set, right? This is like and on this side we're going to use something called an annealed simulation. Oh, let me check that out. Annealed oh, I'll get to it. We'll get to it. Okay, let's just continue. All right. So in this application, right, we're using this on action units, right? So, action units are like, how do I call them? They are let's think of it as the atoms for facial emotions, right? So essentially, if you combine some action units together, it will equate to a facial expression on your face, right? So an action unit relates to some muscular contraction or movement of your muscles or facial muscles. So a combination of those equates to or maps to an emotion. So in this scenario, we'll be using weakly supervision to be able to classify these type of facial action units, right? So the data sets that we'll be using is DISFA, right? And this is the DISFA data set, right? You can reach out to this gentleman over here if you want to get access to this. So it's Denver Intensity Spontaneous database. Hopefully this is not some violation of OPIA right now. But yeah, so he's the owner of the data set. So essentially this is what it's all about. It's a facial action unit data set. It has emotion labels and as well as facial action units, right? So I don't know if I can see any images of the data set per se. Let's check in the images. Okay, yeah. So these, so you see, it looks something like this, right? These are your emotions. However, if you look at here, if I can open this in a new tab or open this image in a new tab. All right, so you see here some of the action units, right? So this is an AU1, which indicates your inner brow being raised, right? So you can see that if you combine that with with this chin raiser, or if you combine it with these two, it could be like, are you sure? Confusion maybe. As you can see, this is signifying maybe upset or thinking properly. And you can see this AG26 jaw drop could either be surprise, right? And here is contempt maybe, or anger or disgust. Anyway, enough about that. Let's jump straight into what we're calling the data pipeline, right? So I have access to the data set. And essentially what I want is, right, I'm going to split this into a 80, forget this one. It's going to be an 80. This is originally before, but it's going to be an 80, 10, 10, 10, right? So I'm making this 80 because what we're going to have here is we're going to have 80 training, right? Percent, 10 for validation, and another 10 for test sets, right? So what's going to happen here is we're going to split our training into 80% unlabeled and 20% labeled, right? I'm going to use this validation as we train the model, right? So yeah, and then once everything is done, we're happy with the performance, we're going to test on our test sets over there, all right? And we'll be using the VGG Net 16 network, right? So it's quite an old neural net or CNN, right? But I think it's still powerful in some ways, and it's easy to understand, right? So let's jump into it. All right, so this is going to be a bit different from the other videos where I code out with you, because yeah, I'm using Colab and there's going to be a lot of resources. So yeah, I'm just going to walk through with the code, and let me just move this all out. Right, so now I have I have the data set, right, and I have it on my G drive. If okay, I have too many sessions. All right, let me see if I can fix that. So these are some of the modules or libraries that I'll be needing. So essentially this notebook is just to prepare this data into this format, and then I'll move to the actually training, right? So there we go, we've loaded that. We're going to use skmultilearn. The reason why I'm using skmultilearn is because this is a multi-label problem. And what I want is to have a even distribution when I split the data sets for the target class, right? So I want there to be the same distribution across the training, validation, and also the test sets, right? So I don't want the model to be trained on some different distribution, then it gets to this and it performs badly, and so on and so forth. So I want it to be the same, similar. Right, cool. Now that is done, right? I'm going to be using pandas, NumPy, TensorFlow, this and this one, right? So this is skmultilearn. It's not the sklearn one. It's completely different, and it's made for a multi-label split, right? And then I'm going to mount my G drive, right? I'm going to need this. This is just a helpful function, right? So essentially I am getting the path of where I've stored it on my Google Drive, right? And then what I'm doing is, since I loaded this originally from the local file, I am renaming this, right? I'm reformatting this, I'm removing that, and then replacing it with this path, right? For every single file, for every single image in the data frame, right? So from then, that's the helper function. Okay, and then this is the load image file function, right? So I want to load my image and turn it into like a tensor, right? 32 bits, 32 tensor, and also create a data set, right? I might not be using this in this in this example, but I'll show you. So now I am mounting my Google Drive, and then let me just pause so that, great. That's done. I've accepted that, and it's still loading for some strange reason. Oh, this has been exceeded. Storage quotes have been exceeded. I wonder what that means, but I'll continue. All right, so essentially what's going to happen is I'm going to set where my raw data is, right? So I have a raw data directory. So for the raw file, right, where I don't touch anything. So let me show you there. Here's my drive, and there we go. So sudo, and then here's our data, and then this is the raw file, and there you go. Right. So okay, so there's nothing there. So this is the data set, right? And then this is the data set with the images, right? Let me see if I can show one or two. They will show. Yeah, okay, they will show. I wonder if it will open up there. Great. So that's an example of an image there. As you can see, this is subject one, and he is displaying anger. All right. So we don't need too much of that. And let me just close that. Great. Okay. So that's that. That's the data set. And then we have this CSV essentially that has what I did to create this. Once it opens is I have the path to the file. I have the name of the file. I have the emotion being described. I have the action units also that was labeled by an expert, right? Fax coder is what they call them. So that's another reason of why we would use weekly supervised learning, because fax coders are skilled labor per se. And so to get one is quite expensive, and then for them to do that job, it takes quite some time. All right, so this is what I've done is now normalized between 1 and 0, or 0 and 1, right? The value of each AU for each image, right? So there we go. That's what it looks like. And then, so now I load this. So that's the directed path, right? To the raw, and then there we have the processed one, right? So I get the raw file that I want. That's this path, and then I load that. Using pandas read CSV, and I show the head, and hopefully, all right, so you'll see this there. Okay, so when I created this, I'll show you. I didn't know about the index to false, right? I'll show you one. So we have that, so get rid of that. Okay, and here's just me checking that we have the correct number of files in here. So quickly, I create a copy of that so I don't mess with the raw file. And then I drop that unnamed column, and then I show that. Okay, so from there, I get all the paths to, I get the path again, right? What am I doing here? So, okay, yes. So what I'm doing here now is I am then calling this function that I defined above to replace the string. And then, so I do that. And as you can see now, it's moved from my local directory path to, okay, that's not supposed to happen. Let's see. Okay, that's interesting. Did I do something? I'm gonna do that again. All right. So let me just run that function again, and then run that. Yes, that's the raw. I'm gonna make a copy of that. Do that. Do that. Okay, so there's that. This is gonna image right and apply the string, and that should be, oh, different. And that's not different. Okay, so yes, that is different. All right, so that stays the same, right? And then that is what I'll be using, the small letter P. Okay. After that's done, I'm going to drop them, but I'm not going to run these, right? So what I do is I drop this and I save this to the process file. I don't want to replace that. And then here I use index as well, so I don't get that unnamed 0 index column, right? And then from here, so what we're going to do here is we're going to load the processed file, right? That's what we do here. And then we get to the head of this and we see that that's what we need. Okay, we just want the file name, we want the emotion, we want the action units, and we want the path to the file on the drive. Okay, then we get the shape, we have the correct number of images and correct number of features. Or should it be features? Target? Let's call it target because the features is the image, right? So this is the target. So we need 12 in this instance. All right, so what am I doing here? I was just playing around a bit. So this is where I was just trying to figure out how to split it properly. But then as you can see it now, I now create my first split, okay? So I put in, here is what I want from here. I select my path, my file name, and my emotions, and I save this to NumPy, all right? And then my target, right? These are the action units, right? Sometimes the motion can be the target if we're doing emotion recognition, but in this instance, we're not. But however, sometimes you might want to be able to see the mapping that your model predicts. So that's why I'm keeping this there, all right, in X. But you'll see I'll only be using this as my true X, okay? So now that I've done that, I'm going to create my first split, X train, Y train, right? So I'm doing this over here. And what I want to get is an 80-20, okay? So the test size is going to be 20, right? Remember, this is going to be 80. Then from there, I'm going to split that test between validation and test. Now I create another helper function. Maybe this can go to the top. Now it's here. So what I do here is, what do I do? So I take a NumPy file and I set the give the columns, and then I return, I say that, so I create another data frame, right? Essentially, I'm creating a data frame, takes in an X NumPy and a Y NumPy, and the values, this X creates a data frame, and then I add this to that, right? To the Y NumPy, and I just return that. Why am I doing that? You might ask. Yeah, I'll show you. Okay, so now I've done that. Oh yeah, it's because this function only it only takes in a data frame, if I'm not mistaken. Could be. It takes a NumPy. But anyway, so this is my second split, right? So I have my Y val and I split it into split 50%, right? So 10-10, they split equally. And then from there, I create a data frame, my validation data frame. As you can see, I have a shape. And then I do the same for my test. And then I test through the test head, right? That's what I want. And then I do the same for X train shape. Just first check that out, right? That's correct. And then I create this now splits. Let me move to here. I create the splits of 18-20, unlabeled and unlabeled. And I follow the same procedures before. I create the data frame for each. And then now I save these to processed, right? Because then when I come back here, I just need to load them. So there they are, right? So we'll get there. Cool. Now, so yeah, so that's just that, me playing around. Nothing too much going on here. So now I'm going to see. Okay, cool. So I think I might have used a lot of my limits today, but so far, let's get to the fun part. Right. So this is from my masters per se. So these are the functions that I would need. I'm not going to run anything I don't think it will let me run. Let's see. Yeah. So let me try and connect with our GPU. Too many sessions. Cool. Let me see if I can terminate one session. Data preparation. Let me terminate that. Great. So now, just like before, I import some modules or libraries that I'm going to use. And then I define some auxiliary functions, right? So essentially functions that I'm going to be needing, and also some classes. So this I use to generate like an output directory for all the models that I'll be training, right? I'm not going to just go over how this works per se, but you can pause and read it. Okay, and then I create a logger, right, to log the whole process as I am running the training and actually evaluating the model, right? And I also have a model points checker, right, as well, so that I can continue. If I lose my progress, I'll continue so I don't have to start from scratch. Okay, and then I have a decay scheduler to control how my learning rate is either increased or decreased. In this instance, it's going to be decayed, so decreased, right, at a specific rate. And then these are some other functions that I needed while I was trying to set the intensity for when a prediction should become 1 or not, right? So it's essentially a threshold that I set for it, right? For it to become 0. I'm gonna call it label binarizer because I wanted 1 and 0s. It could be a better name. And this is one for pseudo-labeling, and this is a subset accuracy, right? So this is accuracy used for multi-label. And then I also have one where I can load my model using the subset accuracy, which is going to come in handy or not. And then I have another one for creating a model, right? Using Keras and TensorFlow, right? So I loading my base model, which is the VGG, and then I add some other layers, right? So I flatten this, I add another dense layer on top of the VGG. Then also another function to load model data. And this is the function that I was talking about here in this over here. So this is how it's going to be working. It's going to annealed simulating or annealed not simulating, but it's annealing, yes, something along that line, right? So it's simulated annealing, thank you. Something used in, I knew it was something used in strength of materials when you're dealing with increasing or decreasing the strength of steel, right? And then we have the function for loading the image. And now here is what I use to train the model, right? So I have a list of epochs and a list of accuracies for each epochs, and so as the training loss as well as the validation loss, right? And yeah, so I go through all of this, and this is the one for the pseudo train, right? So I'll be walking with you in the next videos, right? I'll record how this training works, right? It's using TensorFlow's automatic differentiation tool, right? Which is the gradient temp. It allows you to calculate automatic gradient, right? So see you there. Thank you for watching.